So I am Salim Nahle. I am Program Manager Data and AI. So my role is to develop programs actually on data and artificial intelligence, and also for students, but also for companies. As I am academic manager of executive education at EFRI. I'll be happy to present you today a presentation on generative AI in education. So I'll speak about open source, but not only open source. I try my best actually to convey my ideas, but I would like to say that I'm going to say a lot of things, but nobody, I think, can answer all the questions today. Myself, I'm struggling actually as a program manager to, to see what are the best programs to, develop for our, for our students and for our partner companies. And I think nobody has the, the complete and the exact answer for what is called today by a lot of professionals existential crisis of human race. Okay, so I'm going to, to divide my presentation into 4 parts. The first one is the impact of generative AI on education on the short term today, what's happening for us teachers, but also for our students. And at midterm, as actually generative AI will have an impact on future careers. Then actually as the engineering school, which my engineering school is EFRI, it's an engineering school in EFRI, we train almost 6,000 engineers and specialized students in computer science every single year. So if we want to implement these use cases using generative AI, we want to leverage generative AI so that we use AI as our assistant as teachers, not as an adversary, and to render education assisted by artificial intelligence. So what are the main challenges that actually we are facing today to put these use cases in practice? And at the end of the presentation, I try to do some comparison between open source and proprietary models in this context. So let's start by the short-term vision actually from a student perspective. What's happening in education today? In the past, when we give a research topic or any project to our students, they have to struggle to get information. So we can say that information retrieval was the bottleneck, as they supposed actually to do a lot of research and read a lot of of books and libraries, journals, articles, etc., etc. Then they have to analyze, to synthesize, and then reading. And of course, actually, every step actually has its main focus and main effort. After the internet, and let's say in the years 90, the first part, which is the information retrieval, has become, let's say, easier, has been facilitated by internet. So it's not the bottleneck as before. But still the students shall actually do a lot of effort to read, to analyze, to synthesize, and to generate the final deliverables. What's happening now with generative AI? So with Gen AI, actually students can do the research using these tools. These tools can, analyze the different data retrieved for them. These tools also can synthesize the tools for them and generate the final reports and deliverables. So, and students can enjoy playing PlayStations, watching movies and eating popcorn. So to synthesize the thing, this is actually the students over time, before internet. So we can, schematize the education process as a big and a long ladder, and the students have to climb with a huge burden on their backs, a lot of books, a lot of articles, a lot of, journals. And then after the internet, things become easier, but in all the cases, actually, students should have actually a huge cognitive effort. Today, from a student's perspective, this is the thing. Gen AI can do everything for them, and they can enjoy their life by, watching videos and playing PS, as we can see in the figure. Let's see now that thing from a teacher's perspective, our perspective as teachers. So we speak about opportunities and risks for students. Of course, opportunities, students have further access and faster access to information. Personalized learning, generative AI is a huge assistant as a tutor. Myself as a teacher, but also for all students, I think all of you, we use Gen AI to learn a lot of things. And it's also a very good tool to get instant feedback. Myself as a teacher also, I cannot afford or I cannot actually respond in real time for my students, even when I'm in class. When I'm having 40 students in my class, or even in China, we are opening here a new program in partnership with Wuhan University of Technology. We may have 70 students, so one teacher or even two cannot respond to all students. However, Gen AI tools can assist for getting instant feedback. Actually, accessibility also all the time, 24/7, this is a huge thing. No isolation anymore, so if we are blocked, we have a lot of tools that can help us. However, from our perspective also, there are disadvantages for students. The first thing is the over-reliance. As today, the first reflex of all students, and maybe adults, is to get actually answers from Gen AI. This actually may lead actually to some problems in the future for our students. This may impact their, critical thinking, their communication skills, their writing skills, a lot of things. And we don't want actually our students to be dependent in a negative way on these tools. Surface learning, again, we get answers, we get some fast explanations. As a student, I understand, so I go forward, so this is also a problem. Plagiarism, I think most of universities in the world are suffering from this problem today with Gen AI, because it's not possible anymore to identify what's actually if students are doing their work or not. And of course, we have other risks like biases and inaccuracies, hallucinations that we find actually for everybody. And of course, there is equity issues because, some students actually that have, the means to have, very good tools, powerful tools, and pay, like, for example, ChatGPT, the paid version, or other tools that are integrated actually in development, are a little bit favored with respect to people that cannot afford these prices. So, for teachers, us, as speaking about actually impact, so we have opportunities as we are saving time, we are gaining in productivity and efficiency. Actually, this helps us a lot in preparing our, our exams, our quizzes, our courses, etc. But also for us to get personalized teaching to learn. Actually, as continuous education now is very important for everybody. Content creation, professional development. There are a lot of positive opportunities for teachers. But the main challenge actually as a teacher is, the assessment difficulties. It's difficult today to assess a student, and of course, the topic. I'm not going to go further. But we go back actually to previous, tools, exams on paper, oral presentations, and so on and so on. Teachers actually need to be upskilled and to actually be accompanied, because students go much faster than us teachers actually to master these tools. And this is actually a very important point, which leads actually to a risk of devalued role of the teacher. Because, for a student, actually, they get everything from Gen AI. The existence of the teacher actually is, is challenged today. Of course, still have equity and ethical concerns. Okay, so these are the main, let's say, impact on teachers and education and on students. So as an academic institution and EFRI, what we did, we take the topic, as I think most of the universities in the world, very seriously, and try to actually to bring responses very, very fast. Because the impact is now, the impact is our student. We are speaking about short-term impact. We don't speak so far about mid-term or long-term impact. So what we start, we try to learn what's happening, and then we consult each other, our students, our other institutions, our partners, and we bring up some solutions. Some of the things that we did, we train almost actually all our teachers and our personnel, administrative and student office, etc. in the school on these tools. What is AI, Gen AI? What is the best way to write efficient prompts, etc., etc. And we'll also develop an online course on generative AI, the risks, opportunities, regulations, and of course, many courses on prompt engineering, so that all our students are sensitized, do know how to use these tools actually in a proper and ethical manner. And of course, we started adapting our curriculum in function of this new era that we are living in. So very quickly also the impact on midterm. As actually when we are speaking about education, for example, in engineering actually system in France, 5 years. 2 years of preparatory courses and 3 years of specializations of engineering actually cycle. So if actually for our students that will enter in our school today will get to the market in 5 years. So we have to take into account actually the midterm impact actually on the work. So our responsibility is as engineering school, and I think, is to, goes beyond what students learn today. We have to think, the real question is how AI will impact their career, the way our students will work in the future. This is a very important topic and we have to take into consideration. So we have to understand in detail what's happening everywhere, the impact of AI and especially generative AI on employment. So we have a lot of statistics, of course. Here we are some statistics from, from the World Economic Forum, from OECD, PwC. So 1 year ago, a lot of specialists would prefer to speak about, about augmenting or automating tasks inside a job. One job is a bundle of tasks, so GenAI is to augment. This means that help people to realize their task or automate. Myself, I believe this is not the reality. We can already speaking about AI impacting and automating jobs. So I think we have to be transparent with each self and with our students and with our kids, because I'm also a father of and I have 3 daughters. So there is an impact. We have to identify what are the jobs that are impacted, and we have to identify how the jobs are actually changing, because a software developer or data scientist or data engineer tomorrow is not as a data engineer today. So this is very important for us actually to adapt our curriculum consequently. So here actually again this is a figure from the World Economic Forum. Actually we see to the left actually the jobs that are positively impacted by by AI, where we have more needs, and actually to the right we have the jobs that are negatively impacted, where there is a real danger on the people occupying these spots. Okay, so very quickly, there are a lot of jobs at risk, including all the jobs, including clerical work, content creation and writing, data entry, assistance, first-level assistance, etc., etc., etc. Then we have jobs that are transformed. Software developer, programming is not the same as before, because today, actually these tools can write millions of codes in few minutes, so of lines of code. So this is very important to take into account. Education is changing. For this reason, I'm speaking about I'm presenting it today, and of course the market, etc. And of course we have some jobs that are created. I'm putting here prompt engineer. I don't like it to put it, but unfortunately I'm seeing in France actually some jobs prompt engineer. For me, all of us, everybody, student, professor, teacher, employee, everybody has to be good prompt engineer, because we actually have to prepare ourselves to live with actually AI in the coming years. Okay? So as engineering school, here I'm giving some example. For example, software engineer, in the past, a software engineer did a lot of code. Myself, I was 15 years ago software developer, so I used to like 50% or 60% of my time to develop. Today, software engineers are not supposed to do that to this extent. Of course, they have to develop, and we need very good developers. But it's more that job is shifting toward more supervising, testing, securing AI, etc., etc. For data engineers, the same thing. When we start actually 5 years ago, I created actually a major on data engineering. So I spoke about data pipelines, creating data pipelines. Now a lot of things can be also automated and done by GenAI, by AI. So that there is a shift inside also the job toward data and AI governance, toward data quality, AI evaluation, and so on and so on. And of course, systems engineer and so on. We have a lot actually of impact on a lot of jobs. So we can speak about disruption of some jobs, creation of others, but of course there is a shift inside actually a lot of jobs that we are having today. So to embrace the AI and learn skills, actually we have to train our students and ourselves actually to embrace lifelong learning, continuous education. Okay, this is a very important thing. Things are moving very fast. People are saying that economy adapt to revolutions like industrial revolution, like the arrival of the internet. So it shall also adapt to this new era of AI. So far, I'm not seeing how. Let's say that based on history, this is a pattern that happened in the past. So we expect that But in all cases, things are changing very fast. So this is very important that our students today have the ability to adapt very quickly, be agile, develop soft skills. Very important to develop critical thinking, problem formulation, and framing, creativity, adaptability. These things are very important. For hard skills, there is a demand today in data science and ML ops and AI engineers. We know these things actually change very quickly. And of course, we have to emphasize professional skills like ethics, communication, collaborating, etc., etc. So universities must anticipate the skill shift and embed it into their curriculum. So the first here, in this first part, I would say that actually as teachers in education, we have to see or to look at AI as a partner and not as an adversary. And we have to start thinking of education assisted by AI. Students are becoming already observers than doers. This is not, I think, a good point. We have to educate them, train them to be learners and doers and observers at the same time. Okay? So, in order to, leverage AI in education, we have a problem. So, the first remedy is to use AI to leverage AI in education. So, we have a lot of use cases in which we can embrace AI, we can use AI in order to actually adapt to what's happening now. So these are some use cases for applications that we can build, that we are building, that we are exploring, not ourselves only, but a lot of universities. So having actually assistants, having chatbots, having personalized tutors, having actually developing applications to support, of course, based on AI and generative AI to support students with their assignments, to language translation, preparing exams, etc., etc., etc. So we are doing these applications as a lot of our, I think, partners. And for teachers, as a teacher, I'm using it, okay? I would like also to have a tool, for example, that automates grading and assessment. All teachers would like to have this, this feature. And of course, we have also we have to think how to use AI to identify gaps in student understanding and so on and so on, to personalize experience and of course boost the level of our students. In order to build these use cases, I'm coming here to the next part of my presentation is about how to put AI in practice. Okay? What are the questions that we have to ask at the beginning? What are the implementation challenges? The infrastructure and ethical considerations. Of course, this actually was, what I'm going to say now is also applied for all use cases, not just for education. So, when we start, developing, I think most of you actually are asking these questions. The first thing actually is strategic questions. What the problem I'm solving? I think today, maybe 2 years ago, people, all companies and institutions wanted to do AI just for doing AI. Now the big question is what problem I'm solving? What is the real use case? What is the business need? What is the real requirement? What is the value of AI? Do we need actually generative AI or classic AI exception? And so on. Then actually we have to speak about the choice of the model. We have a lot of models. We have proprietary models and open source. They have the advantages and disadvantages of each of them. Do I train a foundation model? I was in HANGZHOU in May and I visited the University of Bihar. I don't know if somebody of this university is here. And I was really excited by what they are developing. They are developing a foundation model, a multimodal model from scratch. This is a big model. It's already in production. Students are using it and teachers are using it. I don't think that all universities in the world, especially in Europe, have the resources and the skills to build such as applications. So we have also questions about performance, how to test, accuracy. For students, actually, we want also to test their engagement, their learning outcomes at the short term, at mid-term, and so on. And then the biggest questions come when it comes to operation. The cost, pricing, which hardware, how many GPU I need, where I train my model, how many GPU I need for training my model. Once I have a good model, how to deploy on cloud, on-prem. Okay, I have to monitor, to maintain. What about energy and energy consumption and sustainability? All these questions are very important questions to ask. Okay, so quickly, actually, models are getting bigger. This actual slide I did actually 1 year ago. So now I suppose that we have bigger models, I don't know. But if models are getting bigger, this does not mean that actually we get better results. This is already old paper actually in 2022 by Chinchilla, who actually tried to identify the best relationship between the model size and the data optimal size. And they proved that actually, if I have a 1 billion parameter, actually the best factor is 20. So I need 20 billion tokens. This means that if we, trust the work done by this paper, GPT-3 already actually 2 years ago was underutilized because actually the data that was used to train GPT-3 was not respecting this model. And we can say the same thing about GPT-4 and so on. So data is the new bottleneck. So it does not necessarily mean that big models are better than small models. Okay? And of course, this is actually here, I'm saying also about just an estimation about the GPU, the memory needed to train and to deploy these models. But of course, now we get quantization actually. This reduce the memory needed for training and for storing the models, but we still need huge infrastructures. Again, which architecture to be used? I don't know if all of you are aware of that. Today, actually, in the last 2 years, we have a shift to the left. We have actually, most of the companies are developing decoder-only transformers. However, actually, with the basic transformer model, we have 3 architectures. So for education, for companies, maybe actually you can get actually best results actually with encoder-only or encoder-decoder-only. So these are examples of things that you can take into consideration. Of course, and the big question, open source or proprietary. Okay, we have a lot of models today. Some companies like Mistral, like DeepSeek, like Grok have their proprietary models, but also open source models. Others do not have proprietary and others do not have open source. So again, this is a big question, which one to use. For the performance and benchmarking, what I'm going to do, which model to choose depends on what I need to do. For example, DeepSeek today is known as to be known as one of the best 4th generation web code. I think it's staying in the pole position. For reasoning and mathematics, maybe you would like to use Claude or OpenAI ChatGPT 4 or 5, etc., and so on. So there are a lot of tools on the internet and platforms that compare these models actually from a performance perspective. I like this one for performance and benchmarking. I think for people actually working the LLM arena, or now it's just large model arena, in which actually we have actually a ranking of the different models based on the user feedback. And as you can see here, if we see the best models, you will see actually Gemini from almost 2 months is taking the pole position. Then we have, Claude is coming back with Claude 4. Then we have different models of OpenAI. Then we have Qwen, we have Kimi. So the first thing to see here in the top 15 models are Americans and Chinese. And the top 10 are proprietary. And then we see actually some models which are Kimi, Qwen, DeepSeek, that are open source, and all of them are Chinese. Of course, there is the cost. This is the cost actually for proprietary model when you pay actually as you go for the API. Okay, Claude is I think the cheapest one. The most expensive one. For example, here, if I'm seeing if I take an example, for example, Gemini 2.5, we pay per million token $0.3 for the input data and $2.5 for the output data. All these things have to be taken into actually consideration. Then we have actually the big question about the privacy. Okay, so we actually, I think for education institutions and for companies, this is a big thing. You are all aware when you do ChatGPT, actually the free version, your data is used for training. Okay, unless, indicated. And there are a lot of tools, and when your data goes to the cloud, to the provider, okay, we have a lot of regulations in Europe, RGPD, GPDR, AI Act, so these things have actually to be taken into consideration. Microsoft Copilot, which is using GPT under the hood, can be thought as a good solution because it's integrated today in Office 365, and for example, in Every we have Office, like a lot of institutions. So we say, okay, it's the best, simpler way to go, but I think it's not the preferred model by me and by a lot of my colleagues. Then we have the regulatory frameworks. This is a very big question. As you know, in Europe, we have the AI Act. The AI Act is the first world's comprehensive legal framework on artificial intelligence. Its objectives is to ensure that AI systems are safe, transparent, and aligned with the European Union values. So this model or this regulation classifies AI systems based on their risk. There are 4 risks. The first level is unacceptable risk. Okay, so these are the AIs that are forbidden because actually they're due to their potential harm. For example, developing AI that manipulates children. This is completely forbidden. We cannot do that. Then there is actually the AI systems that significantly impact safety or fundamental rights. And when it comes to education, to human rights, to banking, most of the AI tools fall in this category. So we have to take that into consideration also. When we know that the AI Act actually is there, this means also this will impact the way that we proceed with AI development. And then we have limited risk. So these, for example, chatbots that just answer questions, etc. Only transparency is needed. And at the end, actually, some systems do not actually pose any kind of risk. Okay, so based on the risk, so this also have to be taken into consideration. And then actually, if in the case of high risk, there are a lot of guidelines to respect, including transparency, conducting risk assessments, maintaining technical documentation, ensuring a human supervision, and so on. And at the end, we have the implementation. We have a lot of methods. In the last 2 years, we have a lot of RAG systems, Retrieval-Augmented Generation, that have been built, that have been efficient. I tried myself actually to build some of them. I didn't get actually satisfied as much. Now the agentic AI is getting actually much and much, how say that, in the market. So AI agents actually, these are systems that execute tasks, plan tasks, and can have access to API, to APIs actually in a completely autonomous way. So this is actually a thing that's happening today. Of course, we can still fine-tune, either full fine-tune or partial fine-tuning. And for those who have actually the resources and the means, they can build their foundations. So these questions also have to be taken into account. Do I do a RAG, an agent, fine-tuning, partial, full fine-tuning? So all these questions actually shall be answered before starting implementation. Now, let's go to education. So today, as you can see in the different rankings, proprietary models dominate. And in a lot of benchmarks, a lot of tests, for example, GPT-4 achieved near human grading alignment to 0.9499. Huge, okay? Open source models are rising very fast. Llama, Mistral, DeepSeek, etc. For education, we need to balance between accuracy, data privacy, regulation, cost, and adaptability. And I think this is the case also for other domains. So for proprietary models, for us actually, the best or the most important strength is that they are fast to deploy, so which eases the go to the market. Less short-term cost, as we pay as we go. We just pay the APIs. We just pay actually the number of tokens that we consume every single day. And today, in the benchmarking and performance, they are top level. The weaknesses of these models, very costly. At the long term, this is costly. This is closed boxes, limited transparency, and less flexible for education. Now for open source models. The strength is transparent and customized. Customizable, we can do whatever we want. We can build our use cases in a very efficient and customizable way. Lower long-term costs. One day in the different benchmarkings, we have a lot of research on this topic. It has been proven that, for example, a small model like Llama, 8 billion parameter, when fine-tuned correctly to a specific task, perform better than big models like ChatGPT-4. So this is a huge advantage. And of course, adaptable to local curriculum and language. Now, the weaknesses and the challenges. Weak performance so far requires a lot of GPUs, machine learning expertise, very heavy and costly deployment. Because when we develop our model, that's fine. Okay, we can do that on the cloud or with some GPUs. We want to deploy. If in an institution like ours, we have 6,000 students. If they want to access this deployment simultaneously, what we have to do. So here, actually, if we want to ensure quality, we have to invest a lot in infrastructure. So very quick comparison head-to-head. For performance, we've seen actually GPT-4 and the Claude get very important performance actually in education. The open source still so far from getting good performance, but we know that if they well fine-tuned, they can obtain better performance, and this actually happened in the case of, sorry, fine-tuned 8 billion, sorry, Llama 3 for tutoring. For latency and the scale, when we are doing open source, when we're using proprietary models, as you can see with GPT-4, with Gemini, with DeepSeek, there is almost no latency. We do the prompt, we get the answer. It's not the case with actually open source. Okay? Because at the left, actually, they are optimized by the cloud providers, so the vendor absorbs the infra. It's not the case in open source. Even if we want to deploy our model on the cloud, we need actually to manage the scaling with a cloud provider, and this is costly. The cost, actually, I'm finishing. From the left, from the one hand, for proprietary model, we speak about OpEx. On the right hand, we speak about CapEx. And for the deployment, for actually, as we said before, proprietary plug and play and open source, actually, we have to choose on-prem or cloud infrastructure. So the conclusion here is for education, for building AI, for leveraging AI in education, the proprietary models, unfortunately, are just like a Ferrari. They are fast, powerful, and expensive. But as we said, actually, we have problems of privacy, about etc., the regulation, and many things. For the open source, can be actually, seen as a customized electrical vehicle. It's adaptable, sustainable, but requires a lot of setup. At the end, the reality is, open source, when it comes to deployment, is not free, because we have to, to pay a lot of GPUs, infrastructure, expertise. We need high expertise, cybersecurity, DevOps, MLOps, of course, data science, and so on. Okay? So the pragmatic future, I don't know. Maybe hybrid or not. It's up to you. Thank you very much.